Hi, I thought I'd introduce you to DNA, and essentially genes are within DNA, as you'll find out in this week. And DNA is the essence of life. It's all around us. Every living organism on the planet has DNA, and it's so easy to extract and see DNA and your genes using the simple procedure I'll show you today. And all you need is basic kitchen essentials: a little bit of soap solution and some alcohol. So what you start off with is you can use a glass like this, or you can use a tube if you have one of these. Either way, what you need is a small amount of water, just as little water as you can. The next thing you've got to do is chew the inside of your cheeks, and not very hard, not enough to draw blood, but just chew for 30 seconds at least. If you want enough DNA, we need to chew. So I'll have to stop talking now and continue with the chewing. Next, I'll swill the water in my mouth. A bit disgusting this, but if you see the solution, it should be slightly opaque. It's got bits in it. That's essentially your cheek cells floating inside the solution. The next thing you've got to do is put a couple of drops, not a lot, of any liquid soap solution. So here I'm putting a few drops. Mix it thoroughly. So what's happening here is that the soap will break down the cells, and now you need to put this in about 50 degrees. So if you put the kettle on, put half cold and half boiling water in a cup. So I've got some cold water already. That's just about right. And now I'm going to leave this gently, just a bit like cooking, stirring this for about 10 minutes. And the idea is that the heat will start to break down the cells even further. So I just keep stirring it. It's not fully clear, but it will get less opaque, shall we say. And that shows that the cells are now breaking down. And this is the basic principle of using soap to clean grease. Grease is nothing but a fat globule, and this is precisely what cells are made of. It's got a lipid layer which protects the inside of the cells, which is mainly water. So part of that is to break down this lipid layer or this fat layer, and that's why you have to use soap. So once the cells burst open, the DNA is inside the cell, and that will be released into a solution. So now that it's gone slightly less opaque, the next thing you have to do is add some chilled ethanol. Now at home you might have some gin or any clear alcohol with a high alcohol content, like gin for instance. You can't use whiskey obviously, or brandy, because it's colored, or your DNA will come out as the color of the whiskey. So just choose any ethanol or any alcohol source that you may have in the house. It's important to keep it cold. So I have some chilled ethanol in the fridge, which I'm going to show you now. So in this case, I have some chilled ethanol here. And just to make it a bit more visual, I'll just transfer this liquid into a tube I have already. You can continue on in the glass. You don't have to transfer it into a tube. Okay. And the next thing is to pour some of this cold ethanol on the side. And what ethanol does is it precipitates the DNA out of this liquid solution. So the idea is that the DNA is currently dissolved in the soap water. Ethanol will pull this out. And typically what you can do, an additional step if you want, is to break the cells down even further, take some meat tenderizer, make a little solution of that, add a pinch of salt and add that to the solution and keep stirring it in warm water. But you can get DNA even without that step. So just to make it easy today, I've avoided that step and gone straight for the ethanol. Ethanol is an organic solvent. It wouldn't dissolve in the liquid. So it'll form a layer that is above this soapy layer. Let it stand for a couple of minutes. So now you can see there's the oxygen bubbles, as you can see between the interface of the soap solution and the organic solvent above. You can see little trapped oxygen bubbles, and around that is the DNA. And that looks like stringy cotton fibers. And if you leave it over time, you'll get more and more DNA precipitating out. But that is essentially your DNA. And typically, how do you know that this is DNA and not just some gunk or muck? Now, if we were in the lab, what I would do is use some dye like ethidium bromide or luminol, as you've seen on crime scene detective series. You spray it with DNA with that and it will fluoresce under ultraviolet light, and that shows you that this is DNA and nothing else. So you can do what you like with this. For example, you can carry it around in the form of a necklace. And here's one I've made earlier. So this is, I put some blue food coloring in this just to give it a Bath blue color. So that's the color for the city of Bath, and that's my necklace.